This is going to be the first theorem that I think Math Marbles will learn. This is lesson 90, the triangle inequity theorem. You're going to hear a lot more of these by the time you get to high school geometry. In this lesson, watch for how we understand what this theorem actually means, how we set up different inequalities to test the theory, and how we use it to successfully determine if three side lengths can create a triangle. We are going to use the triangle inequality theorem. If you're not sure what that is, I'm going to plug in an additional video that actually shows this in action. What this pretty much says is that when I have three lines, in order for them to make a triangle, for all those three lines to meet, then I have to have one thing be true. I can take all the sides, here's A, B, and C, and anytime I add up two of the sides, they have to be bigger than the third. So why does that happen? Because if I have a really, really long side, it's not going to be able to reach. So these two sides have to be long enough to connect with that third side. So that's where this comes from. So it pretty much says that any combination A plus B has to be greater than C, B plus C has to be greater than A, and A plus C has to be greater than B. So we're going to check every combination, and if these three inequalities are true, if true, you have a triangle. All right, so let's test this out. We're going to use these three numbers, 8, 10, and 15. So I'm going to just try this out. Is 8 plus 10 greater than 15? Yes, 18 is greater than 15, so that inequality is true. Let's try B and C. Is 10 plus 15 greater than 8? Duh, 25 is absolutely greater than 8, so that one is true. Let's do the last one. So I just take the last two numbers, 8 plus 15, are they greater than 10? Yes, 23 is greater than 10. So this satisfies the triangle inequality theorem. Hit pause and jot this down into your notes. Can a triangle have a side length of 15, 12, and 9? So we're going to do the same thing. 15 plus 12 is greater than 9. Is that a true statement? Yes. So I'll try a different combination. 12 plus 9 is greater than 15. 21 is greater than 15. Yes. And lastly, I'm going to try 9 plus 15 is greater than 12. 24 is greater than 12. Yes. So now I'm going to answer this as a full sentence. Yes, the side lengths create a valid triangle. I confirmed this using the triangle inequality theorem. And that's it, Math Marbles. So that's all you have to do for today's lesson. You're just going to stop and try different combinations, and as long as all three different combinations, the sum of two sides is greater than the third, then it passes. It is a valid triangle with those side lengths. Hit pause and jot this down into your notes. I did want to give you one valid example that actually shows a theorem that doesn't work. What if I have a triangle that's 1 inch and another side is 1 inch and the other side is 10 inches? So just imagine what this would look like. It means that one side is going to be really long And the other two sides are just going to be these short little things. It's not far enough to actually complete the triangle. If you were to try this out, you would get 1 plus 1 is greater than 10. You would see right off the bat that that inequality isn't true. The other two would be. 11 is greater than 1 and 10 plus 1 is greater than 1. But if any one of these doesn't work, then this will not create a triangle. Okay, Math Marbles, I just want to make that point and give you an example that does not work. This is the final one, so hit pause, jot this in your notes, and let's get into practice. Good luck on your checkpoint, and I will see you in the next lesson.